Absolutely. Let's dive even deeper and break down the highland climate into simpler, easy to follow parts. What is highland climate? Highland climate is the climate found in high mountain areas. This climate is special because it changes as you go up the mountain, even though you're staying in the same place on Earth. Why does the climate change on mountains? 1. Temperature drops with height. As you climb up a mountain, the air gets cooler. For every 1,000 meters, or about 3,280 feet, you go up, the temperature drops by about 6.5 degrees Celsius. So the higher you go, the colder it gets. 2 example, if it's 30 degrees Celsius at the base, bottom of a mountain, then 1,000 meters up, it will feel like 23.5 degrees Celsius. If you go another 1,000 meters up, it will feel like 17 degrees. This is why the top of a mountain is much cooler than the bottom. Comparing a mountain to traveling from the equator to the North Pole. Think of Earth as divided into different climate zones from the equator, the middle of Earth, up to the poles like the North Pole. Near the equator, it's warm and tropical, lots of sun and heat. Toward the poles, it gets colder and eventually icy. On a mountain, as you go up, the climate zones change similarly. Base of the mountain bottom feels warm, like the climate near the equator. Middle of the mountain, cooler like spring or fall weather. Top of the mountain, very cold, almost like the climate near the poles. So moving up a mountain is like traveling from a warm place near the equator to a cold place near the poles. Climate zones on a mountain. As you go higher up a mountain, you pass through different climate zones. 1, tropical zone, warm, found at the bottom of the mountain. Feels warm and sunny with plenty of plants. 2, temperate zone, mild. As you climb higher, it feels like spring or early fall all year. Still some trees, but it's cooler. 3, cool zone, higher up it gets cooler with fewer trees and more evergreen trees. This area feels like a cold forest. 4, polar zone, cold. Near the top, it's very cold. Few or no trees can grow, maybe only some small plants. A 5, frozen zone, snow, ice. If the mountain is tall enough, the peak might be covered in snow and ice all year. Even in summer, the snow doesn't melt. Real life example, a mountain in the tropics. Imagine a tall mountain near the equator where it's usually warm. 1, at the bottom, it's hot and tropical with lots of plants like palm trees. 2, a little higher, it starts to feel like a cooler forest with trees like oak and pine. 3, even higher up, now it feels more like a cold forest. Trees are shorter and there might be evergreen trees like spruce. 4, near the top, it's really cold and only small plants like mosses can grow. There's no forest here because it's too cold. 5, at the peak top, if it's a very high mountain, the top might have permanent snow. It's similar to the polar regions where it's always frozen. Why is highland climate important? 1, unique plants and animals. Each zone on a mountain has different plants and animals. For example, you might find monkeys or tropical birds at the base, but small hardy animals like goats near the top. 2, different farming areas. In some regions, people can grow different crops at different heights on the same mountain. For example, they may grow coffee in the middle, cool area where it's not too hot and not too cold. Summary, highland climate means the climate that changes with altitude height on a mountain. As you go up a mountain, the temperature drops, the climate zones change, just like moving from the equator to the poles. A single mountain can have many different climates, from warm at the bottom to frozen at the top. So, climbing a mountain can feel like a journey from a hot place to a very cold place, all because of the change in altitude. Let's dive deeper into highland climates in a very simple way so you can understand every detail. What is a highland climate? Highland climates are found in mountain areas. The weather on mountains is different from other places and it changes as you go up the mountain. These changes are affected by a few main things. 1, how high you are on the mountain, elevation. 2, what shape the mountain has. 3, which way the mountain faces the wind and sun exposure. 4, where the mountain is located in the world. Let's break down each of these one by one. 1, elevation, height above sea level. Elevation means how high you are from sea level. As you go higher up a mountain, the air gets thinner, which means there's less pressure. The temperature drops. Higher places are cooler. This is called the lapse rate. For every 1,000 meters you go up, the temperature drops by around 6.5 degrees Celsius. Example, imagine standing at the base of a mountain where it's 30 degrees Celsius. If you climb up 2,000 meters, the temperature might be about 17 degrees Celsius at that height. Why it matters? As you go up, not only does it get cooler, but the air holds less moisture, less water in the air. This affects plants, animals, and weather at different heights on the mountain. 2, shape of the mountain. The shape of a mountain can affect how weather behaves around it. Some mountains are steep with sharp peaks, while others have gentler slopes. A steep mountain might block wind or force it to rise quickly, which can cause rain. Example, if the mountain has a steep side facing the wind will rise quickly when it hits the mountain, cooling down and causing rain. On the other side of the mountain, it might be dry as the wind loses its moisture on the way up. Why it matters? The shape of the mountain can decide where it rains and where it doesn't. Different shapes can make different mini-climates on each side of the mountain. 3, exposure, which way the mountain faces. Exposure means the direction that the side of the mountain faces, towards or away from the wind and sun. The windward side is the side facing the wind. This side usually gets more rain because the wind pulls and makes clouds that bring rain. The leeward side is the side that's often drier because the air goes down, warms up, and doesn't form clouds as easily. Example, windward side, think of it as the wet side of the mountain. It gets more rain. Leeward side, think of it as the dry side. It's protected from rain because the wind lost its moisture on the other side. Sun exposure. East-facing slopes get the morning sun. This makes them warmer in the morning, but cooler in the afternoon. West-facing slopes get the afternoon sun. They stay cooler in the morning, but are warmer in the afternoon. Exposure to wind and sun. Exposure to wind and sun affects rain and where plants grow. People may build houses on the warmer, sunny side of mountains and grow crops there too, especially in colder places. Number 4, location of the mountain. The location of a mountain affects its climate. The weather on a mountain depends on how close it is to the ocean. Coastal mountains get more moisture. Whether it's near the equator or the poles, closer to the equator is warmer. Closer to the poles is colder. If it's in a stormy or windy area, like a place with monsoons or cyclones. Example, a mountain near the coast, like in Norway, might have lots of rain because ocean winds bring moisture. A mountain far from the coast, like in Mongolia, might be drier because it doesn't get as much moist air. Why it matters? A mountain's location changes the types of plants and animals that can live there. Different places have different levels of rainfall, temperatures, and even sunlight. Highland climate zones, different climates on one mountain. Mountains have many different climate zones as you go up. These zones are similar to traveling from the equator to the poles on Earth. As you climb, you start in a warm climate at the base. Higher up, you enter a cooler zone with different plants and animals. Near the top, it might be very cold with snow and ice all year round. Each mountain level has different plants, animals and weather because of the changes in temperature and moisture. Special facts about highland climates. 1. Rain and snow. Mountains cause rain because they force air to rise. As the air rises, it cools, forms clouds and then rains. In rocky or dry areas, mountains can heat up in the sun, which can cause thunderstorms in the afternoon. 2. Water sources. Mountains get a lot of rain and snow, so they are often the source of rivers. In summer, snow melts from mountain peaks and flows down, making rivers that run all year. 3. Biotic islands. Mountains can be like islands in the sky. They have special plants and animals that need cool, wet conditions and can't survive in the lower, warmer areas around them. Key points. Highland climates are found in mountain areas and change with height. Number 2, they affect elevation. The higher you go, the colder it gets. Shape of the mountain affects rain and wind. Exposure to sun and wind, one side is usually wetter and warmer. Location, near ocean or far, near equator or poles. 3, mountains have different climates at different heights. It's like different worlds stacked on top of each other. Number 4, rain from mountains supports rivers and snow melting in summer keeps them flowing. Each mountain has a mix of small climates, wetter, drier, warmer, cooler, creating unique habitats and making mountains special places with rich life. All right, let's dive even deeper into understanding highland climates and how they change as we go up a mountain, but let's keep it as simple as possible. What are highland climates? When we talk about highland climates, we're focusing on climate zones found on mountains. As you climb higher on a mountain, you pass through different climate zones, each with its own weather, temperature, and types of plants and animals. It's like traveling to different parts of the world, but instead of moving far away, you're just moving up. Imagine climbing a mountain, step by step. Let's go step by step up a mountain and explore each zone, especially looking at the Andes Mountains in South America. 1. Starting at the bottom of the mountain. Altitude, 0 to 1200 meters above sea level. Climate zone, tropical rainforest. Weather, warm and very wet, it rains a lot. Plants and animals, dense forests with tall trees. Lots of plants and animals like monkeys, parrots and frogs. Here it feels just like being in a jungle or rainforest. It's hot and humid with tons of plants and life. 2. Going higher, around 1200 to 2400 meters. Climate zone, subtropical weather. A bit cooler than at the bottom. Still warm but with less rain. Plants and animals still green with forests, but the trees are a bit shorter and the plant types start to change. This area feels like moving away from the hot rainforest to a cooler, less tropical place. It's still nice and green, but not as humid. 3. Climbing further up, around 2400 meters, climate zone mesothermal, like a Mediterranean climate. Weather, comfortable temperatures, not too hot or too cold. Plants and animals, shrubs, smaller trees and more open spaces. This zone is a lot like the climate in the Mediterranean, places like Southern California or Italy. It's warm during the day, but the nights are cooler. 4. Even higher, around 3600 to 4800 meters. Climate zone, weather, it's getting cold, and the air is thinner here. Plants, animals, mostly small, tough plants like grasses and shrubs. Trees can't survive at this height. At this level, it feels more like a chilly mountain zone. There's less plant life, and it's mostly hardy plants that can handle the cold and wind. 5. The top, above 4800 meters, climate zone. Perpetual snow and ice, like a polar climate. Weather, extremely cold with snow and ice that never melt. Plants and animals, almost no plants. Only snow and ice. It's too harsh for most life. This is like being in the Arctic. It's freezing and the ground is covered in snow and ice all year round. Why does the climate change like this? As you go up a mountain, temperature drops. The higher you go, the colder it gets. The air is thinner and holds less heat, so it feels colder. Air pressure changes. High up, the air pressure is lower, which also makes it colder. More precipitation. As moist air moves up the mountain, it cools down and releases water, causing rain or snow, especially on the side of the mountain facing the wind. Think of it this way. Every time you climb 300 meters up, it's almost like traveling 500 to 1,000 kilometers toward the North or South Pole in terms of how much cooler it gets. Other factors that affect highland climates. 1. Mountain shape. Mountains can have different shapes, which affects how the wind moves and how much rain or snow falls on each side. For example, if one side of the mountain is steep, the air is forced to rise quickly, making more clouds and rain there. This side is called the windward side. The opposite side, the leeward side, is usually drier because the air loses its moisture as it crosses over the top. 2. Exposure. Windward slopes, the side facing the wind, gets more rain and snow because the air is pushed up, cools and drops moisture. Leeward slopes, the other side where the air descends, is drier and warmer. Example, if you've ever noticed one side of a mountain looking lush and green while the other side looks dry and brown, this is why. 3. Sun exposure, slope aspect. Slopes that face the sun, like those facing the equator, get more warmth, making them better for farming or living. East-facing slopes get morning sun, which warms them up early, while west-facing slopes are warmer in the afternoon. 4. Location where the mountain is located matters too. If it's near the coast, it will get different winds and might be wetter. If it's deep in a continent, it might be colder and drier. Summary. To sum it up, highland climates are like stacked layers of different climates. At the bottom, warm rainforest. In the middle, cooler, comfortable zones with shrubs and grass. At the top, cold, icy and snowy. Each part of the mountain feels like a different part of the world as you go up, from hot to cold, from rainforest to polar ice. Highland climates show us how height affects weather and life, creating unique zones full of diverse plants, animals and weather. All right, let's break this down by word, line by line. So it's as simple, and we'll go through air pressure and winds in highland climates to make sure you understand every part. Air pressure in climates. 1. What is air pressure? Air pressure is the weight of the air above us. Imagine you're at the beach at sea level. There's a lot of air above you pressing down because the whole atmosphere is right above you. 2. How air pressure changes with elevation. When you start climbing up a mountain, you're moving higher and higher. As you go up, there's less air above you pressing down, so the air pressure gets lower. At about 5 kilometers or 5,000 meters up, the air pressure is half of what it is at sea level. 3. Why this matters for people. Our bodies are used to a certain amount of air pressure. When we go too high, like above 3,000 meters, 3 kilometers, some people feel sick at high elevations. Some people get symptoms like nosebleeds, bleeding from the nose, feeling sick to the stomach, headaches, trouble sleeping. So many people prefer to live below 3,000 meters where the air pressure feels more normal and doesn't cause these problems. Winds in highland climates. 1. Wind and friction on mountains. On a mountain, especially on peaks, the highest points, there aren't as many obstacles like trees or buildings. With fewer things to block the wind, the friction or resistance is low, which means winds are much stronger than at lower, flatter places. 2. Types of winds on mountains. Mountains have special kinds of local winds that change direction depending on the time of day. Let's look at 2 main types.
Upslope.
During the day, the sun heats up the mountain slopes. Warm air rises up the slope, creating what's called an upslope wind. These winds can make clouds on the mountain, which sometimes grow big enough to cause afternoon rain showers. Downslope katabatic winds. At night, the mountain cools down. Cold air, being heavier, moves down the slope to the valleys. This is called a downslope wind. 3. Other local winds in mountain regions. Some mountain areas also have specific local winds that are famous for their strength and effects. Here are a few examples. Mistral in southern France, Bora along the Adriatic Sea, Santa Ana in southern California. These winds are very strong, cold and dry, and usually blow from high to low areas. How winds affect weather on mountains. 1. Clouds and rain from upslope winds. When warm upslope winds blow during the day, they can create big clouds like cumulus or cumulonimbus clouds over the mountain. These clouds can bring heavy showers or thunderstorms in the afternoon because of the rising warm air. 2. Clouds at night from downslope winds. At night, when cold downslope winds blow into valleys, they sometimes push moist air up. This can lead to clouds forming in the valleys. If the valley has a special weather setup called a temperature inversion, where it's warmer higher up and cooler at the bottom, then stratocumulus clouds may form. 3. Example of nighttime rain in places like the Magdalena Valley and the Llanos of Colombia, both in South America. The valleys get lots of rain at night because the downslope winds push moist air upwards, making big clouds and rain. Summary. Let's put it all together. Air pressure decreases as you go up a mountain, which can make people feel sick at high altitudes. Mountain winds are stronger and can change direction based on the time of day. Upslope winds during the day bring warm air up the mountain and can cause afternoon rain. Downslope winds at night bring cold air down, which can create nighttime clouds and rain in valleys. Highland climates are full of these interesting patterns because of how air pressure and wind change with altitude. All right, let's take this one step at a time, very slowly and simply. We'll break down how air moves mountains and what happens to temperature, pressure, and humidity. I'll explain types of winds that happen in mountain areas, like the Fohn and Chinook, so it's all clear and easy. Mountains and moving air. What happens? 1. Air moves across land in a horizontal flow. Air normally moves horizontally from side to side, like wind blowing across a flat field or open space. 2. What happens when mountains get in the way? When this moving air hits a mountain, it can't keep going straight. The mountain forces the air to go up over the mountain and then come back down on the other side. Why going up and coming down changes the air? When air goes up a mountain, it rises and cools because the pressure decreases as it gets higher. When air comes down the other side, it sinks and warms up because the pressure increases as it gets lower. What changes in the air as it moves up and down? 1. Pressure and temperature. Going up, air pressure drops as the air goes up the mountain and the temperature gets cooler. Coming down, air pressure increases as the air goes down the mountain and the temperature gets warmer. 2. Humidity, moisture in the air. Going up, as air rises and cools, it can hold less water. This can make it release moisture in the form of rain or snow. Coming down, as air sinks and warms up, it can hold more water. This can cause it to dry out and lead to evaporation. Winds and their effects on mountains. 1. Winds that rise and cause rain or snow. When air goes up the mountainside, it cools and often produces precipitation like rain or snow. This is why one side of a mountain where the air rises can be wet with rain and snow. 2. Winds that descend and cause dry, warm conditions. When air comes down the other side of the mountain, it warms up and dries out. These warm, dry winds are common in many mountain areas and often melt snow quickly. Types of warm, dry winds: Fohn, Chinook, and others. 1. The Fohn wind in the Alps. In the Alps mountains in Europe, the descending warm, dry wind is called the Fohn. The Fohn wind blows down the side of the mountain, warming up, drying the air, and sometimes causing snow to melt very quickly. It is often linked to cyclones, a type of storm passing through the area. Number 2. The Chinook wind in the Rocky Mountains. In North America, along the eastern side of the Rocky Mountains, a similar warm, dry wind is called the Chinook. Like the Fohn, the Chinook is also very warm and dry and causes snow to melt fast when it blows. 3. Other similar winds in different mountains. There are other mountains around the world where warm, dry winds form because of the same up and down air movement. Salmon in Persia, Iran, nor'westers in New Zealand. In all these places, these winds can clear snow off the ground quickly and leave the air feeling warm and dry. How cyclones help create these winds. A cyclone is a storm with powerful rotating winds that can move across large areas. When a cyclone passes near mountains, it can affect how the air moves, forcing air up and over the mountains. This is one reason why Fohn, Chinook, and similar winds happen near mountain areas with cyclones. Summary. Let's summarize this simply. Mountains block the air, forcing it to go up and then down the slopes. Going up the mountain, air cools, pressure drops, and rain or snow can form. Going down the mountain, air warms up, dries out, and causes evaporation. Special warm, dry winds like the Föhn in the Alps and Chinook in the Rockies can quickly melt snow and dry the air. Cyclones can help create these winds by pushing air up and over the mountains. This is how mountains and moving air create different weather patterns on each side. The warm, dry winds, Föhn, Chinook, make mountain regions interesting places where weather changes quickly and can affect the local climate. All right, let's dive deeper and break it down step by step in the simplest way possible. We'll look closely at each part to understand how mountains affect rain, snow, and water. 1. Precipitation, rain, snow in mountain areas. Why do mountains get more rain? When air moves toward a mountain, it often brings along moisture, tiny water droplets in the air. As this air moves up the mountain slope, it starts to cool down. Cooler air can't hold as much water, so the moisture in the air turns into rain or snow. This process is called precipitation. Imagine carrying a glass of water up a steep hill. As you climb, it's harder to hold the water, so it spills over. That's what the air is doing with its moisture as it rises up the mountain. Why does the amount of rain vary in different mountains? 1. Low latitude mountains, near the equator where it's warmer. These mountains get more rain up to a certain height, about 1,500 meters or 4,920 feet. After reaching that height, the rain decreases as you go higher. Number 2, middle latitude mountains, farther from the equator where it's cooler. In these mountains, the higher you go, the more rain you get, all the way up to the top. The rain doesn't stop increasing until you reach the summit, the highest point. Why this rain is important in dry, arid areas. 1. Mountains bring water to dry places. In places that don't get much rain, like deserts, mountains can be the only areas where there's enough rain. This rain helps plants grow on the mountains, even if the land below is dry and barren. 2. Rivers flow from mountains to dry lands. Rivers often start in these rainy mountain areas and flow down into dry lands, bringing water. Example: the Nile River starts in rainy mountains and flows into Egypt, which is mostly desert. Another example is the Colorado River, US, which flows from rainy mountains into dry regions, bringing much needed water. 3. Hydropower, electricity from water. This mountain rainwater can be used to generate electricity as it flows downhill through hydroelectric dams. This is helpful for people who live in lower areas near the mountains. When do mountains get more rain? 1. Summer is rainier than winter. Mountains usually receive more rain in the summer than in the winter because the air is warmer and can carry more moisture. 2. Daytime is rainier than nighttime. Mountains also get more rain during the day than at night because the sun warms the air, helping it carry moisture up the mountain. 3. Windward and leeward slopes, the two sides of a mountain. 1. Windward side, wet side. This is the side where the wind blows toward the mountain. As the air is forced upward on this side, it cools down and releases moisture as rain or snow. Because of this, the windward side is usually very wet and has more vegetation, plants and trees. 2. Leeward side, dry side. After crossing the top of the mountain, the air starts moving down the other side. As the air moves downward, it warms up again. Warm air holds more moisture, so it doesn't release any rain. This makes the leeward side drier. This dry area on the leeward side is called the rain shadow. 3. Higher parts of the leeward side can still get some rain. Sometimes the air keeps rising a little bit even after crossing the mountain top, so higher slopes on the leeward side may still get a little rain. This means that even on the dry side of the mountain, some places near the top can be a bit rainy. 4. The snow line, where permanent snow stays on a mountain. 1. What is the snow line? The snow line is the lowest point on a mountain where snow stays all year. Above this line, snow doesn't melt completely, even in the summer. Below this line, any snow that falls in the winter melts away when it warms up. 2. How the snow line changes with seasons. The snow line moves up and down based on the seasons. In summer, it moves up because warmer temperatures melt the snow. In winter, it moves down as it gets colder and more snow builds up. 3. How latitude affects the snow line. Latitude means how far north or south you are from the equator. Closer to the poles, like near the Arctic or Antarctic, the snow line is much lower because it's colder there. Near the Arctic Circle, the snow line might be at sea level because it's so cold that snow can stay right down to the ground. 4. Factors that affect the snow line. Latitude closer to the poles means a lower snow line. Season, snow line goes up in summer and down in winter. Sun exposure, slopes that face the sun have a higher snow line because more snow melts there. Slope steepness, steeper slopes may have a different snow line. Other local conditions like wind, temperature, and humidity. Example of how mountain weather can change quickly. Mountain weather is very unpredictable and can be different just a few yards apart. One side of a mountain might be covered in mist while the other side is sunny and clear. In one spot, there might be a heavy hailstorm, while just a few hundred yards away the sky could be clear.
Summary, quick overview.
Mountains make rain by pushing moist air upwards where it cools and releases moisture as rain or snow. Low latitude mountains get rain up to a certain point, then it decreases. In middle latitude mountains, rain generally increases as you go higher. Mountains are important in dry areas because they bring rain, which supports plants, rivers, and hydroelectric power. Windward sides are wet, while leeward sides are drier, creating a rain shadow effect. The snow line is where permanent snow starts, and it varies with season, latitude, sun exposure, and slope steepness. This explanation shows that mountains don't just add beauty to the landscape, they shape the climate, water sources, and even the types of plants and animals that live in and around them. Mountains have a big impact on the weather and life for miles around. Let's break down each part even more simply. We'll go step by step to understand how plants grow in different layers or zones as you go up a mountain. What is vertical zonation? Imagine a mountain as having layers of different plants. Each layer or zone has different types of plants because temperature, sunlight, and rainfall change as you go higher. Why does vegetation change on mountains? 1. Temperature. It gets colder the higher you go up a mountain. But 2. Rainfall. The amount of rain varies at different heights. 3. Sunlight and wind. At higher elevations, sunlight can be strong and the wind is faster, which can make it hard for plants to survive. So each zone or layer on a mountain has plants that are adapted to these conditions. Layers of plants on a mountain. Now let's look at each zone or layer from the bottom of the mountain to the top. Upper 1, bottom zone, plants like the ones on the ground level. This zone has plants similar to the ones found in flat areas around the mountain. For example, if there is a tropical forest near the mountain, then you'll see tropical plants like palms or ferns here. 2. Middle zones, forests with different types of trees. As you move up the mountain, the types of trees change. Deciduous forest, this is the first type of forest you reach as you climb up. Deciduous trees lose their leaves in winter. This helps them save water when it's colder. Common trees, oaks and chestnuts. Coniferous forest. Higher up it gets colder and now you'll see coniferous trees. Coniferous trees, needle-like leaves, which helps them retain water and stay green all year. Common trees, pine, fir and spruce. 3. Alpine zone, grasses and small shrubs. As you go even higher, it gets very cold and dry. It's now too harsh for big trees to grow. In this zone, you mostly find grasses, shrubs and small, tough plants. Why only grasses and shrubs? There's less rainfall and cold winds. Only hardy plants that don't need much water can grow here. 4. Snowline, where permanent snow starts. Near the top, it's so cold that snow covers the ground all year. This is called the snow line. No plants can grow here because it's too cold and there's no soil or warmth for plant life. Example of vertical zonation in the Himalayas. The Himalayas, the highest mountains in India, show clear examples of these layers of vegetation. One, wet hill forest, 915 metres to 1830 metres. Here you find evergreen trees like oaks and chestnuts that keep their leaves all year. These forests are mostly found in the eastern Himalayas. 2. Other trees. Trees like ash and beech also grow here. At lower spots you may find sal trees. 3. Special plant types. Climbers. Plants that climb up trees like vines are also common here. Epiphytes. Plants that grow on other plants like some orchids are found here too. Why do these zones exist? 1. Temperature changes. As you go higher up it gets colder, so only plants that can survive cold can grow in the upper zones. 2. Rainfall pattern. Forests are found in zones with the most rainfall. Alpine zones have less rainfall, so only grass and shrubs grow there. 3. Short growing season. At higher places, the time available for plants to grow is shorter because of the cold. Only tough plants that can grow quickly in short seasons survive.
Summary: as you go higher up a mountain, temperature,
rainfall and sunlight change. This causes different types of plants to grow in different zones. Lower levels have plants from the surrounding area. Middle levels have forests with deciduous and then coniferous trees. Higher levels, alpine zones, have grass and small shrubs. Top levels are snowy with no plants. This setup means mountains have a variety of plant life close together, creating unique mini-worlds on one mountain. Sure, let's go through each type of forest one at a time, breaking down the details to make it as simple as possible. Number 1. Subtropical pine forest, where it's found on the slopes of mountains in the Himalayas at heights between 915 meters and 830 meters at the height of a tall hill to a small mountain. Main location, found between 73 degrees and 88 degrees east longitude, so mainly in the Himalayas. Main tree, that cheer pine, also known as cheer or Indian pine. Why it's important? Cheer pine trees are useful for their wood and resin, a sticky substance that can be used to make things like glue or varnish. Special case, in a specific area called the Khasi Hills, a different type of pine called cassia pine grows at around 1220 to 1525 meters. Easy example. Imagine a hill covered with tall, thin, evergreen trees. They stay green all year. These are cheer pine trees. People use these trees for various things because they're strong and useful. Number 2. Subtropical dry evergreen forest. Where it's found? In the western Himalayas, which get less rain than the eastern side. Height found at lower elevations between 450 meters and 1215 meters, similar to the height of smaller hills. Main tree, wild olive trees are the most common here. Why wild olives? Wild olives grow well in drier conditions because they don't need a lot of water. Easy example. Think of a hillside with shorter trees that don't need much rain to survive. These are wild olives. This forest is more common on the western side of the Himalayas, where it's drier. 3. Subtropical hill savanna. Type of vegetation, mostly grasslands. Big open areas with mostly grass and only a few trees. Where it's found? Above 1370 meters in the Himalayas. This type of grassland stretches from the western Himalaya to the Burmese border in the east. Main plants, different types of grasses, including ones called arundinella and themda. Easy example. Imagine a high open space on the mountain that's covered with tall grass and very few trees. This grassland area, or savanna, is spread across the Himalayas and is home to many types of grasses. Number 4. Moist temperate forest. Where it's found, higher up in the Himalayas, between 525 meters and 355 meters, pretty high up on the mountain. Main trees includes a mix of trees like oaks, laurels, pines, cedars, chestnuts, and rhododendrons. Trees that are usually big, have different types of leaves, and can survive in cooler and wetter places. Especially in the wetter eastern Himalayas, east of 88 degrees E longitude, the forest has coniferous trees like pines and firs mixed with broad-leaved evergreen trees. Extra plant life. There's bamboo growing below the larger trees in some places. Easy example. Picture a cool, lush forest with many different trees, some tall with needle-like leaves and others with broad leaves, oaks. In some spots, bamboo plants grow under the taller trees, making the forest look green and thick. Flash damage number 5. Dry temperate forest. Where it's found? In the inner Himalayas, where it's colder and there's less rain, less than 100 centimeters per year. Type of rain. Much of the precipitation here comes as snow, not rain. Locations. Common in areas like Kashmir and northern Sikkim. Main trees. Trees here include deodars, a type of cedar, junipers, oaks, and ashkapover. The ground is covered with various kinds of grasses. Easy example. Imagine a cold, dry forest where the ground is often covered in snow. The trees, like deodars and junipers, are hardy and can handle cold conditions. There's also grass covering the ground, which adds some greenery even though the area is pretty dry. Summary of the forest types in the Himalayas. 1. Subtropical pine forest has chirpine trees found at around 915 to 1830 meters. These trees are useful for wood and resin. 2. Subtropical dry evergreen forest has wild olive trees found at lower heights, 450 to 1215 meters on drier slopes. 3. Subtropical hill savanna, mostly grasslands found above 1317 meters, stretching across the Himalayas. 4. Moist temperate forest, higher up has a mix of trees like oaks and pines, with bamboo in some areas. 5. Dry temperate forest found in the cold inner Himalayas, with hardy trees like deodars and some grasses on the ground. Each forest type is different because the mountain's height and weather change as you go up. This means you see new types of plants at each level, creating unique zones of natural vegetation. Alright, let's go through each type of mountain vegetation in a super simple way, explaining exactly what they are, where they're found, and why they're special. Think of climbing a mountain, and as we go higher, we see different types of plants along the way. 1. Montane temperate grassland. Where it's found, at about 2,000 meters, about 6,500 feet up the mountain. Type of vegetation, mostly grasslands, meaning open fields mainly covered with grass instead of tall trees.
Why it's here?
It's cooler here than lower on the mountain, so it's perfect for grasses to grow. The soil isn't deep enough for large trees, but grasses can survive well. Example, imagine walking on a gentle mountain slope filled with green grass, almost like a natural carpet spread over the land. This area is open and grassy, almost like a high mountain meadow. 2. Alpine forest, where it's found, up from 2,800 meters to 3,660 meters, 9,200 to 12,000 feet. Types of trees. This forest has birches, pines, silver firs, junipers, and rhododendrons. Forest type. These forests are dense and shrubby. They're packed with plants, but the trees are shorter and closer together than in warmer forests below. Why it's special? At this height, it's colder, so only hardy, tough trees can grow. The air is thin and the soil isn't very deep, so these plants are adapted to survive in harsher conditions. Example, imagine a cool, dense forest of tough trees with thick, small leaves. These trees are used to the cold and windy climate, and they look strong, standing close together to survive the mountain's challenges. Alpine grassland, where it's found, higher up, around 2,135 to 2,440 meters, 7,000 to 8,000 feet. Type of vegetation, grassland that turns into pastures. Pastures are areas with grass where animals come to graze, eat the grass. Use for grazing. People bring animals like sheep and goats here to graze in the summer, as these grasslands offer plenty of food for them. Adaptation. The plants here are adapted to withstand cool temperatures and dry conditions. They don't need much water and are strong enough for the cold. Example, picture a high mountain field with short grasses waving in the wind. It's a peaceful open space where you might see herders with their animals. The animals feed on this grass during the warmer season. 4. Snowline and alpine tundra. Snowline at around 880 meters, 16,000 feet. You reach what's called the snow line. This is the height where snow stays all year because it's so cold that it doesn't melt. Timberline. Before the snow line, you reach the timber line, the height where trees stop growing. It's too cold and the soil is too thin for trees here, so only small plants can survive. Alpine tundra. The area above the timber line is called alpine tundra. Here, only very small hardy plants grow, like moss and tiny flowers. It's very similar to the tundra found in the Arctic. Example, imagine climbing higher and seeing fewer trees until there are none left. Now, the ground is covered with small plants that are close to the earth to stay warm. It's a chilly open area that almost looks like the frozen lands up near the North Pole. Understanding mountain vegetation as you climb higher. 1. Temperature changes. As you go higher, it gets colder, so plants need to be stronger to... 2. Rainfall changes. Different parts of the mountain get different amounts of rain, so plants in each area adapt to either more rain or less rain. 3. Sunlight and soil. At higher places, sunlight is less intense and the soil is thinner. This makes it harder for tall plants to grow. 4. Wind. Strong winds make it difficult for big trees to survive, so only small tough plants can make it. Each level on the mountain has its own type of vegetation, almost like layers. Here's a quick summary. Montane temperate grassland. Grassy fields around 2,000 meters up the mountain. Alpine forest, short, dense forests with tough trees like pines and rhododendrons found between 2,800 and 3,660 meters. Alpine grassland, open grassland that turns into pastures for grazing animals found between 20.35 and 24 meters. Alpine tundra, very high up, cold and windy, with only small hardy plants above the timber line, near the snow line at 4,880 meters. These different layers of vegetation create a beautiful, unique mix of plants on the mountain. The higher we go, the more the plants have to adapt to cold, thin air and strong winds. This is what makes mountain vegetation so special and interesting.